Hello everyone, welcome back to my channel Study with Saf. I am Safia Khalid and I'm happy to launch the new series, MSRIT IoT Lab series using Raspberry 4B. As the name suggests, this is focused on the IoT Lab curriculum of MSRIT and hope this tutorial is helpful to anyone who's watching it. Starting with the first experiment, which is blinking an LED. Just like how we have the hello world as the beginning program in the case of all the programming languages, I'd like to think blinking an LED as the hello world of the embedded and the IoT domain. So let's get started. We begin with the resources required. For this particular experiment, we need the Raspberry Pi 4B microprocessor, a single LED, a current limiting resistor of value 330 ohm, and a few jumper wires to make the required connections. You can either connect all the components directly, else a better way to do is to take a breadboard and to make the connections on the breadboard. Moving ahead with the circuit diagram. This over here is the basic circuit diagram for this particular experiment. Towards the right is the electrical symbol of an LED, plus and minus signs corresponding to the anode and the cathode respectively. And when we look at the actual symbol of an LED, the longer leg is the anode and the shorter leg is the cathode. The basic connection is such that we connect the GPIO pin, any GPIO pin of the Raspberry Pi, to one end of the resistor. The other end of the resistor is in turn connected to the positive or the anode of the LED, and the negative side of the cathode is connected to the ground pin of the Raspberry Pi. The other connections are required for opening the Raspberry OS and typing in the code and executing it. So we have the power supply given through the C port on the Raspberry Pi. The HDMI port, or rather the micro HDMI port of the Raspberry 4B is used to connect to the monitor screen, and the USB ports are used to connect the keyboard and mouse. Next, we have the basic Python code for this particular experiment. As we can see, the first few lines having the import statements are the libraries required for the rest of the commands which we use in the program. We are importing rpi.gpio with the alias name as GPIO. So anywhere GPIO is used, it's taken from this particular library. The time library is used for all the delay statements, such as time.sleep. Next, we are defining a variable named pin. And in this particular experiment, we are using the GPIO pin 4 of the Raspberry, hence pin is equal to 4. When we come to GPIO.set mode, essentially the programming wise, we have two different modes in which we can use the pin numbering of the Raspberry board. We are going to be using the GPIO.bcm mode. BCM stands for the Broadcom mode. And by this, what happens is whatever pin number we are defining here, it corresponds to the GPIO pin 4. The basic difference is on the Raspberry board, the GPIO pin, example pin 2 may not be the actual pin 2 of the board. So when I use the GPIO.bcm board, when we look at the pinout diagram, the GPIO pin 4 itself is used wherever pin is mentioned. Next, we have the GPIO.setup command, wherein we are setting the GPIO pin 4, the direction of which is going to be set as an output. We then have a forever loop, and essentially within this forever loop, we are going to be controlling the turning on and off of the LED. First and foremost, the pin is set to be true, in which case the LED turns on and it remains on for the next 2 seconds, after which we are setting the pin as false and it remains off for the next 2 seconds. And this continues as long as there is no keyboard interrupt given. Keyboard interrupt essentially are the control signals such as Control C or Control Z. Whenever that is given, these two commands get executed, GPIO.cleanup and exit, GPIO.cleanup, basically it resets all the GPIO pins. The previous state of a given GPIO pin is erased so that whenever we run a new program, it starts afresh. And exit just exits out of the program. Also, as mentioned in red, the code is available in the description box below. You can check it out and run it accordingly. Now coming to the demonstration part.
So as per the circuit diagram, these connections have been made. Yellow is the GPIO pin 4 of the Raspberry and purple is connected to the ground pin. The resistor one end is connected to the GPIO pin 4 and the other end is connected to the anode of the LED, and the cathode shorter leg is connected to the ground. And now to basically execute the code, I'm going to the start menu, programming. I'm using Genie programming tool. I have already typed in the code here. I'm compiling it. There are no errors, so compilation finished successfully. And I'm clicking on run. This terminal opens. Since I've not given any print statement, it's a blank terminal. And when I go to my output, I can see that it's blinking every 2 seconds. In order to stop it, I can just give Ctrl+C and the execution stops, and correspondingly the terminal window is also closed.
That was the basic demo of the entire experiment. In order to summarize, on the left is the circuit diagram for blinking an LED, and the result is given in the form of the truth table. Whenever the GPIO pin 4 is set to true, that means the corresponding LED is turned on, and since we've given a delay of 2 seconds, it remains on for the next 2 seconds, after which the GPIO pin 4 turns false, and in that case the LED also turns off and it remains off for the next 2 seconds. And since we've given this under the forever loop, it keeps continuing unless any keyboard interrupt such as Ctrl+C or Ctrl+Z is given. That was the end of the first experiment. The purpose was to blink an LED using Raspberry Pi.